this session, session 6, is going to be managing the user experience. And there are kind of two users I'm talking about. And one is the remote operator. And then there's a section at the end we're going to talk about what's it going to look different, what's going to be different when you're a DXer trying to work a DXpedition or contest operation where there is where remote access is in the game. Things are going to be a little different, and that's okay. We just need to be trained. I mean, we've all seen changes in the game. For example, if you're in a contest and you're working some mega station with some mega operator, and you know the guy, and you give him a call, you know he should hear you, and he doesn't come right back to you, and you go, "What's going on?" You realize he's talking to someone else on another frequency on the radio, and you have to give him a break and not keep calling the guy endlessly thinking he just is a lid and he can't hear you. You have to accommodate for the fact that he's operating 2, or in the case of some operators, 3 radios at the same time. And so the same sort of thing will happen in DXpeditions as we introduce the network delays and how it affects certain things. But the topics we're going to talk about here in the experience is the system management overview that George will talk about, which is what somebody on the team has to see what's going on with the system, and there's a view that they need. I'm going to pick up local and remote access applications and how they work and which ones are available, and we'll have a lot of discussions about the audio that Gerry will cover. So George, why don't you give a kind of an overview of what it is that you observe with the Jarvis operation while it was underway?
The most important thing to understand about remote operators is that it's really a dual operator system. So every radio is operated by 2 people. What's called the control operator, that would be me back on the boat, monitoring the stations, and then the operator who is making the contacts. Officially, it is the control operator that's in charge of the station. Just think of a broadcast station. A broadcast station is a control operator, and it has announcers and et cetera, et cetera. So the remote operators are the equivalent of the announcers, and the control operator is the equivalent of the engineer who is monitoring everything. And that's really an important thing to keep in mind. So the control operator can turn the radios on and off, can reset them, stop it, restart it, whatever. The actual remote operator can make QSOs. The remote operator operates basically N1MM. That's his main interface, and he's accessing, N1MM runs on the boat on a computer, and he's remotely accessing N1MM using AnyDesk remote access software. And in that environment, there are a couple of good things about that. One is that legally we are in the clear because the control operator is present locally. The remote operator is operating the N1MM, which controls the radio remotely, which means that anything goes wrong, the log is local. We have the log, we don't lose the log, and we don't have the log scattered around between, 20 different operators, which would be, unmanageable. And the hardest part of remote operators is controlling the team. It's not always that the best and the fastest guy is the best remote operator. The remote operators have to have a lot of discipline, and we learned over time they have to be very tightly controlled. Because, these are all ham guys. They all have their home station. They turn on their laptop, they look at it through AnyDesk and say, no, that's not how I do it. And they start moving windows around, and they start resetting things, and start changing parameters. And stopping them from doing that is the hardest thing ever. Not only that, some people have the bad habit of using the mouse, the cursor, to go around and clicking on things. What is this? What is this? Click, 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 and pretty soon you have a mess that's not working. So really the hardest part is getting the remote operators do just what they're supposed to do and no more, and don't mess things. It's like herding cats. And we were using Slack as a chat platform, and then started using also WhatsApp messages. But that kind of a control is really important. So and what's also important is that the remote team has a team leader. They have an issue, they go to the team leader then makes the decision, okay, we're going to change something. Well, you have to change things every now and then. Then that team leader contacts the boat, okay, can you change, like radio 3 is getting interference from radio 5, can you change the filters or rearrange it or move the antenna, whatever it is. So, but those changes have to be organized. There's no way that can be made without coordination. That's really the most critical part. And then, of course, we use very simple access control. That's any desk with an AnyDesk address and a password. In the future, we'll have to figure tighter control because eventually somebody will break into the system. But of course, at all times, the local control operator can shut a radio down, and more often than not, it reset the radio, restart the radio, and do other things. And we monitor a lot of things for each one of these remote stations. And indeed, in this remote local, what we call hybrid environment, the local operators spend a good deal of their time supporting the remote operators. Like on Jarvis, I was on the air maybe 4 hours, 6 hours a day, no more. Because the rest of the time I was fixing antennas, resetting generators, all kinds of things go wrong, like watering the gasoline. Oops. Well, it's not an easy problem to fix when it's out on the island and it's in the middle of the night, and now you have to take the tender out and go through this narrow channel, through the surf and all that to the beach and go and replace basically the tank, which has water in it. So there are always issues. There's always something going wrong, and you got to be able to fix it relatively quickly, because a de-expedition is simply a race against time. You have a certain time allocated. You got to make your 100,000 or 100,000 plus QSOs, otherwise you let people down. And every hour costs a lot of money. Every day costs about, $30,000 or something. So that's every hour is over $1,000. You don't want to waste. You don't want to waste time. So everything's got to be, the local operators got to be on top of it all the time, just all the time. And that means they have less time for QSOs. But the great thing is that the remote operators are extremely productive because they work from home and they have all the comforts of home. A de-expedition is tough on people. A lot of people don't realize that if you're on a de-expedition and it's a traditional de-expedition, your schedule is very hard. Because what do you do? You work, I don't know, for 3 or 4 hours, then you go eat quickly, sleep, maybe do some work, and then you're up again and work more on the radio, and that goes on for 2 weeks. So it's pretty tough. While with remote operators, you can distribute the load, they all can have plenty of rest, and they're fresh, and they are very, very productive. I mean, we have CW operators doing, 200 QSOs an hour? Yeah. That's pretty good. And when you have, 4 radios going at that rate, your QSO count goes up, which is, the big deal is not that our QSO count goes up. It means that the QSLs going out is going up. So there's more people who will have that particular entity. And that's really the goal, that's the main purpose of the entire operation. So that's got to be all tailored to that. Make QSOs, more QSOs. And that's another big benefit of this RIP type operation, that on Jarvis we had 4 stations on the air 5 hours after we left the boat first. We left at 7 o'clock towards the island, at 12 o'clock, we had 4 stations running with remote operators. In the afternoon, we were building more antennas, more ribs, but the 4 operators were running full speed. So by the end of the first day, we had something like 8,500 QSOs. Traditional DXpeditions normally make on the first day 0. So that's one big benefit of remote operators.
Okay, very good. I'm going to talk for a couple of minutes about the remote desktop applications. Having lived in this world for a number of years, I've kind of grouped them into 2 types. First is where it's a pure peer-to-peer kind of connection. If you have knowledge of the IP address of the remote station, you would use a software like TightVNC and a new capability that the same team who did TightVNC came up with Remote Ripple, which is sort of a tool that lets you manage multiple sites at the same time, which I find very effective. At times I will open up windows, remote access windows to all of my remote sites in a contest to manage things on the fly. And those require knowledge of the IP addresses and managing the port forwarding on the router. Essentially, there's 2 apps. There's on the remote site, the site with the radio and the antennas, you would run TightVNC server. It sort of, once you install it, it sort of is launched on boot up if you elect that option. And when the PC wakes up, it launches that server function. And then the operator would then launch a TightVNC viewer, which requires you to enter in the IP address and the port that is associated with that in your remote site. And then it'll establish a connection, and you get a fully high fidelity rendition of what's available out at the site. Sometimes there are some issues that you have dissimilar configurations of video configurations. For example, if you have a widescreen monitor, ultra wide at home, and you have a 1080p monitor out at the remote site, you have to mess around with what part of the screen you might want to use on your home monitor. We tend to adopt the 1080p monitor view. And we've gone to having PCs out at the remote site that have more than one video interface, and we'll install video monitor emulators, which enable desktops which can be built with more than one desktop, extended desktops, and then we can use the ultra-wide monitor and get more than one desktop available on a view. So lots of things to use to help build the station view that you want for your particular function. Now the ribs use I think is a similar 1080p view, and everything is set up so that everything you need to run the station is in that one view. For contesting, you may need a lot more antenna control functions and other things, and you may want to use a hybrid of a ultra-wide at your operator position and multiple 1080p monitor desktops on the remote PC. The other type of remote access software is slightly different. Like AnyDesk, which we use extensively on the RIB operations last year. What it does when the remote PC boots up, it sort of registers with some server in the world somewhere. I think it's in Russia. And therefore, anybody who wishes to connect to it will try to connect to its address, and it polls that same server, and it gets the instructions it needs to then create a direct connection to that desktop. So they're really very similar. There's no performance difference between them. They both have very, very comparable kind of video quality. And there are some video options, and I think there's some effect on the bandwidth of the connection. You
can change the video quality, whether it's whether it's full 32-bit video, or you can change it to be more responsive. There's a lot of options to experiment with. So if you have a low bandwidth connection, you can.
Right. Another option is RustDesk, and one nice feature about that is the code is available. It's fully it's available software. There's no no matter
it's
what,
free.
it'll never
source software.
There'll never ever be a fee for RustDesk.
Never ever be a fee for RustDesk.
Not so about any of the others. And the other thing about RustDesk is they have the way of building your own server.
Sure. And let me comment a bit about both AnyDesk and RustDesk and TeamViewer. They all use this technology. It's typically called a rendezvous server. And what they do is they discover where you are on the internet and who you are, and so they can connect each other. It doesn't matter where the server is in Russia, because your actual video screens are peer-to-peer. Yeah. They connect peer-to-peer. The server's purpose is just to find each other. On RustDesk, you have the option of installing your own RustDesk server, so you can put that somewhere at your shack or somewhere else and allow people to connect the RustDesk sessions. It's more under your control. Yeah. But
and last I looked, there's like 18 other options out there, and they're all, TeamViewer has a particular feature that's annoying to me, is that if you start building a network of more than like about 6 or 10 remote sites, it sort of figures out that you're a pro, and it will ask for you to pay for a license. So you got to be a little cautious about that one. We don't anymore. TeamViewer is not what we go to first. It used to be for a while. Everybody, say we'll see on TV. But I think RustDesk and AnyDesk are really perfect for hams, and they don't cost you anything at all.
And the other thing is they're good for redundancy. If you're in a contest, 48-hour contest, if you're using their rendezvous server and it goes down, you're down. But you can install RustDesk on AnyDesk on the same desktop. There's really no penalty. But you can switch. You switch both the station and the remote ops to the other server, and away you go. So it's great for redundancy.
As an experienced remote operator, a remote system manager, you need more than one option. Okay, sometimes the AnyDesk server is down, and has happened to me many contests where in the middle of things it just goes away, and we have. After the first time I did that, we had a new policy that we have to have 2 ways of getting to every computer. So it's just for redundancy. It's recommended you don't put all your eggs in one basket. Another couple things. Most of these apps have embedded FTP, which is really cool. If you're moving logs around, it's perfect. You can access the directory of both the host PC, the server PC, and the client PC, and you can move files either way, which is perfect for a system manager, having a tool ready to do for doing FTPs. And also some of them, I think most of them have an audio option. I think RustDesk and Chrome Remote be able to take the server PC audio and stream it back to the operator. It might compete with Mumble, except you can't get audio back.
That's right.
So it's a talk only mode. So it's okay if you're monitoring, some camera or something out there, but it doesn't work for what we do in ham radio.
So I'm going to talk to how you can add remote ops to both either your contest station or your DXpedition simply, not overly complex. And this diagram just kind of shows you what you do. Ned was just talking about remote desktops. Number one key to doing this is having all your automation in your station available from your desktop in your station. So if you have antenna controls like switches, antenna switches, rotors, any other amplifiers, amplifier software, all of that is in the station, and a lot of people will have that right now. They have everything automated to a desktop. Once you have all that automation to a desktop, what do you have to do to add a remote operator? Well, if you have we all probably have transceivers now that have cat control. If they have cat control, it means that you're controlling it with some other software on your desktop. For example, N1MM or DXlog, or a lot of software can control a rig from the desktop. So that gets you controlling your station remotely using just AnyDesk. Now the remote operator has AnyDesk and can pretty much operate. Well, you may want to do FT8. If you want to do FT8, you're all set. You can just remote desktop into your station, run FT8. You don't need any audio. You're set to go. Let's say you want to do CW. Well, what I'll show you and what I'll talk about here is I use something called Mumble. And Mumble is an audio conferencing server. It's very high performance. Mumble it's a very active open source project. It's designed for and used by gamers, real-time online gamers. And what's important to gamers? Low latency. Why? Because literally they die if they get the audio too late. If their partner tells them to shoot this other guy and they don't shoot him, they could die. So just kidding aside, it's a very, very good performant audio system with low latency. The key to using Mumble, and what we did on all of George's DXpeditions that I was involved in, we have Mumble is a client-server architecture, which means that there's a server in the cloud somewhere. Well, my idea was to put a server anywhere in the world that's close to either the operator or the station, okay? So you get very, very low latency and low jitter from my Mumble server located somewhere in the world back to your station or to the station you're remoting to. This makes the remote picture much, much better. Plus, you're not reliant on, if you have a server at your house where your station is, you're reliant upon that to be your internet provider to be up all the time. So I have 14 Mumble servers around the world. 7 of them in North America, but I have one in London, one in Frankfurt, I have one in Tel Aviv, I have one in Sydney, Australia, I have one in Singapore, and I have one in South Africa. And how well does that work? It works very, very well. In another slide, I'll be showing the station that I remote there. But let me get back to the slide at hand. Go back. Yeah, slide at hand. So how does, if you're operating a contest station and you want this remote guy to operate, how can he operate? You've already set up AnyDesk so he can remote in and be there. Well, Mumble can be running all the time as well. So how do you switch between remote and local operators? You tell the remote operator, go. All he has to do is get on, and he's got Mumble audio coming back from the station. And if he's on CW, he's ready to key with N1MM using macros, using CW macros. So in this direct method that I'm talking about now for CW, it's keyboard CW only. But Ned's working with me on a project. It's coming along pretty smoothly, which is the ultimate. If you're a paddle CW operator, you'll be able to do paddle CW over AnyDesk and Mumble. And the way that I do that is quite unique. There is a open source project called Windows Morse Keyer, and this is a true CW keyer that works on your desktop on Windows. And you can connect the paddle various ways, but one of the ways is through a serial port. So you connect your paddle to a serial port, and this Windows keyer outputs tone. It's a side tone. So it doesn't key a radio, it keys a side tone. So what I do is, using software, connect the output. You can monitor your CW audio locally, and then I take that audio and I feed it to the input of Mumble. It goes to the remote end. On the remote end, I wrote a piece of software that takes the CW signal, runs it through a bandpass filter and some debounce logic, and it then keys a DTR line on a serial port, which means that you can hook up a transistor switch, and away you go. You plug that into the key jack, and now you're generating CW on the remote end. It has latency. It's going to take time for the CW to go across the wire, but you're listening to a local side tone, so you can send on a paddle perfectly. So a few more months, probably weeks, a few more weeks to make that work, but that'll all be free software, and you'll be able to do remote CW using Mumble and AnyDesk. For sideband, obviously you have to get the mic audio into the radio. So Mumble, of course, Mumble is two-way. A lot of guys have trouble because they'll try to use a ham headset and plug it into a computer. It doesn't work. Well, gaming headsets are better, or computer headsets, because they have electret condenser microphones, and that's what computer inputs are designed for. Anyway, mic audio goes over Mumble, comes over to the other side, and if you have a modern radio, it probably has a USB audio interface, and with that USB audio interface, you can you do transmit audio. Although there are some limitations depending on model. You can also connect to the mic input and speaker output of any radio. You could take any radio that has cat control and connect it to Mumble through some isolation transformers and go to the input and output of your sound card. So this remote is extremely, extremely easy to do. Okay, next slide. So there are right now there are two really good possibilities for software doing remote. One of them is called Sonobus. Now, Sonobus is low latency. It's low latency, high performance audio. Some of the people who aren't hams who use it are musicians. It's so low latency that they can play together from multiple locations. A lot of contesters like Sonobus because it's stereo audio. Mumble is not stereo. Why do they want stereo audio? They want to do SO2R remotely. So they want to be able to listen to each channel in each ear. So it does that natively. Sonobus is not a client-server based architecture. It's peer-to-peer. So it tries to connect from your internet connection to the station end internet connection. It uses advanced network discovery to figure that out. So it usually can always figure that out. It's been used in DXpedition successfully with Starlink, so it can work over Starlink. The good news about Starlink is that the latency has improved tremendously over time, so it's getting very good. If you're thinking about the remote, the most important factor is really not latency. I mean, latency might bother you a little bit because things are delayed. The most important factor is jitter. And what is jitter? If you don't know what jitter is, it's the instantaneous change in latency. So one packet of data might take 100 milliseconds to come. The next packet may come at 90, and the next one might come at 110. Well, that's about 10 milliseconds of jitter, which is pretty high. Using my Mumble servers around the world, from almost anywhere to almost anywhere, less than a millisecond of jitter. So it makes a huge performance. And jitter is what causes breakup in the audio, especially on CW. If you can miss characters with breakup. But if you reduce the jitter, it works. Sonobus does have a peer mode, so you can have more than one operator connected at the same time. The disadvantage of that with Sonobus is, as you add each remote operator, the bandwidth from the station side increases. So if you have one person listening, it's a certain amount of bandwidth. If you have 10 persons listening, it's 10 times the bandwidth. It's excellent for internet paths with known latency and good bandwidth. And again, it's a good solution for SO2R. Next slide. Okay, Mumble server, this is what I've been talking about. So this is a low latency, high performance with a central server. Doesn't support stereo. They've been working on it for years, but I guess there hasn't been high demand, so stereo's not done. Clients connect to a server with a public address. Why is that important for ham radio? Doesn't matter what kind of internet you have. You can be on cable, you can be on DSL, you can be on fiber, you can be on 4G LTE cellular data, you can be on Starlink satellite. It will work and you can connect every time because you don't have to know. You don't have to know as a station owner or a remote operator what your IP address is because AnyDesk and Mumble both resolve that automatically. So you can always connect. For a contest station, for redundancy, okay, you've got cable at home. What if it goes down? If you have a 4G LTE cell phone, you can be back on the air in 30 seconds. For the expedition, same thing. So what's really nice about multiple remote users with a mumble server is, for example, on George's DXpeditions, it's only receive audio. You're driving the receive audio, one channel. So there's one stream of receive audio. The server can stream that out to 45 remote operators if they all want to listen to what's going on. Doesn't affect the bandwidth going to the yacht, going to the boat.
Right.
So you're not as you add more operators, you're not increasing the amount of bandwidth coming from the boat, at least for audio. And there's always a budget, right? You always have a bandwidth budget. You don't want to be bandwidth starved on these kind of operations because that starts to cause all kinds of problems. So the other thing about mumble in multiple locations is with Starlink, your path changes all the time because you're never connected to one satellite, as these satellites are LEOs, so they're moving all the time, and you switch off between satellites. So, for example, in N5J, one of the servers, mumble servers I had was in Seattle, Washington. Well, from most of the United States, very low latency to Seattle, but Starlink has I think a 4 terabit link to this data, very close to this where my mumble server was. So we had great performance out of that. But then we had operators in Japan and in other places where the best server was in Sydney, Australia. So we allowed the remote operators, each client has to be connected to the same server. So the remote operators had a list of servers and they could say, oh, okay, Sydney's working better for me, and they would switch over to the Sydney server. So you give them that redundancy to go to different servers and overcome issues you might have at another one. So I operate a station 7Q2T. It's Don Jones's station in Malawi, and I operate that remotely from New Hampshire. And one of the challenges we've been having in remote operation is having good SSB, because you have to encode the audio at your remote station and send it over the internet. And in a lot of cases, this remote audio would break up. So you need a really high-performing mumble server. So I tried, for Malawi, I tried a server in South Africa from sort of a brand X supplier, and it didn't work on sideband. It just wasn't good enough. So then I switched to using Amazon AWS micro EC2 instance, which is a very, very small Linux server on Amazon. It's to run it for a year is about $75. But you can sign up for a free tier for a year so you can run it. Well, in Malawi, the internet connection at his station is 4G LTE cellular. I was getting 39 milliseconds to my server. So 39 milliseconds from Malawi to South Africa, and then about 150 milliseconds from New Hampshire to South Africa. And that's because Amazon is big. It has a lot of infrastructure. So it has a lot of pairing partners, which gives you really low latency. I was blown away at the audio quality. SSB is perfect. And every time I connect, it's perfect. It's like being right there. So this is the challenge. This is the advantage of mumble servers out in the world. One other thing I'll talk about is a slide I did here last year. Everybody says, well, remote is impossible because if you have high latency, and if I do CW, I'm going to be later in the pileup, or I'm going to lose time during the contest. Well, this is I looked at a QSO over Starlink, and if you look at the slide, 19% of the QSO time is latency. Sending an exchange in this whole thing, 4,144 milliseconds. This is at 35 words a minute. The first little piece there is the caller radio propagation. It takes 26 milliseconds over the air. That's what the speed of light, okay, over this path. Then the internet radio to Starlink, so from George's yacht up to Starlink, 170 milliseconds. Starlink to the remote op, if you have a good connection in North America, it can be as low as 50 milliseconds. then the operator has to type the call sign, and assuming a typing speed of 80 or 100 words a minute, just typing the call sign takes 1,733 milliseconds for the average call sign. And then you have to send the keystrokes to the radio, which is the N1MM command, and on that delay, 210 milliseconds. And then there's the reply radio time. So if you look at the absolute latency of it all and compare it, it's only 19%. So it's very, very little. And a lot of times, and what my personal advantage is, if I think as an engineer, I'm going to say, oh my God, there's too much latency. But as an operator, if I think as an operator, I have no trouble. I have no trouble doing very, very high speed rates on phone or CW. And you just have to get used to it.
Very good. Let's talk for a couple of minutes about the experience from the DXer. While the 19% increase in time is a small number and involved in overall QSO, it does get in the way of a very fast-paced interaction between a caller of a DXpedition and the DXpedition operator. It gets in the way. All right. If traditionally, I mean, if you've ever worked a pileup with Italians, you almost have to break your own pileup to get a QSO going, because they call endlessly, and to get the pileup to stop to be able to finish a QSO is hard in the first place with zero latency. When you add latency, you add another a part of a second or more where someone isn't hearing their call being started from the DX station, and they'll call again. And what will happen often is that the DX station will be transmitting while the DX caller is calling a lot. And in the early adventure with the Starlink access to the stations, we tried sideband early on, and we had real challenges. I remember the first hour I ran a sideband pileup, I was totally spent. I didn't get very high rates, and we were struggling with delays. But I think, as you mentioned, Starlink got better and better through that year. But we decided early on not to do sideband remote at this time, and that more work was needed to study that behavior. You have anything to say about that, George?
About sideband?
About sideband remote operation?
Not really.
Yeah, good. Okay. All right. And so we decided as a team that the local team would do sideband, would cover the sideband demand. And I hate to say it, but the explosion of FT8 has been at the falling down of sideband activity in DXpedition pileups. And so the local team could easily handle demand for sideband, and that you needed the large teams of remote FT8 operators to carry.
So I was going to speak a little bit about latency and CW operations. So I did a lot of operating from N5J on CW, and yes, people, the community has to change a bit when they know there's remote operators on the other end. I would say 45% of my QSOs, I had to call the station maybe 3 or 4 times. 3 or 4 times, because they anticipate, they hear the end of my transmission, and they send their call 5 times, or 3 or 4, and it's just crazy. And I'll be calling the station, and when I let up my key, they're still calling me, so because they missed it. So it just takes a little more patience. You can still dump your call if you do it at the right time, but imagine 45% of my QSOs had to repeat the call many times, and if we could get that number down, that's a lot more QSOs in the log.
But really, the trick there is to slow down a bit, and wait half a second or a second, and then respond.
Yeah, I'd say count to 3 and call. Another idea on CW is to change the message format, possibly to send their call, their report, send their call. That's being done a lot on RIDI these days in order to stop repeats, and it may be a way of dealing with that.
Yeah, I do. I was doing a lot. I would send their call, send the exchange, and then send their call again.
Right. Now, maybe you give some updates on AI-generated voice and where that might be going in terms of a de-expedition operation.
Okay, yeah, this is another thing I've been experimenting with. So we all know, most people, and DXers and contesters know what super check partial is. Does everybody know what that is? Yeah, super check partial is a list of, especially in contest, there's one for DXing and there's one for contesting. And it's the most active call signs. And years ago, I wrote a program that would take all of the super check partial calls and create audio wave files of them. Well, in both contesting and de-expedition, it really got a kick in contesting where SO2R operators on sideband wanted to have their voice calling CQ on one while making the exchange on the other. But when making the exchange, they also wanted to use their voice and interact a lot. So, with the advent of AI, there's generative speech to text. So you can generate a voice from text that sounds absolutely, you couldn't tell the difference between a human and AI voice. Well, the cool thing about it is you can use your own voice as a template for generating files. So a bunch of people have done it already. They've done the super check partial, and they operate the whole contest without saying a word. It's just like on CW. Great for people if they have a disability, but what's really great is if you do these, if you encode all the super check partial and all the DX partial, you put that, for example, at Georgia Station, you put all the files on the boat. So the only latency is the latency of sending them over the satellite. If it was a remote operator on sideband, your voice has to be encoded at your remote station, wherever that in the world. That encoding takes some time. Then it has to be sent over the internet to George and down to the transceiver, and then sent up again. So you eliminate all that side of the delay, and it's advancing very, very quickly. The cost of doing this was somewhat prohibitive in the last year, but as you know, the AI space is taking off big time, and their prices are coming down. So it's going to be a real cool technology for de-expeditioning.
All right, so something to look forward to. Okay, is there any questions from the audience for this panel? We knocked them dead. We answered every one of your questions. Okay, that's it for now. We'll see you at the top of the hour for the next session, which is station integration and testing.